Hey Terry, hey Amog, hey Nathan, can you guys hear me?
Yep.
Hi.
Hi. Terry, how is it going at your end?
Yeah, good, thanks. And you?
Amog, you are new to this or you have been here before?
I've been in the other meeting with the other time zone.
Okay.
Yeah.
Probably should make it one time zone, I believe. In a sense that find a compromise time between the two and have run one of them.
I don't know. I think I'm in the middle, so both of them works for me. One for in the morning, one in the evening. So I don't know.
Yeah. So probably since I don't have a background on your side, I'm all like and I see Gang.
Yes, sure. So I'm a tech entrepreneur. I'm you know, like a hands-on technical guy. I was a contributor to Kubernetes personally. You know, I am, because in my previous company I was the CTO, so that's what I do. And now I'm looking nowadays for innovation in the MLOps world. So I thought, hey, it can be a good idea to contribute to the community and learn, and you know, collaboration. So I'm here to help.
Great.
You're most welcome.
Is there a specific area of interest? I mean, in MLOps where you want to focus on, or is it in general, you know, the field?
So right now it's super early. I'm just learning because I'm trying to be humble when I'm approaching new stuff. I think that the monitoring area is really interesting because there are no good solutions over here, at least from the interviews I'm making. Again, I'm here to learn and help, and you know, I think that's the best way for me to know. It's like when you contribute to open source, you learn a lot, you know.
Yeah, no, makes sense, definitely. Yeah, so I think, I mean, when you look at the monitoring, typically there is the general monitoring ecosystem, right, which has emerged around Kubernetes, right, which is the more infra level monitoring around CPU, GPU utilization, incoming request response times, tracing. So that, if you're looking at a machine learning platform being built on top of Kubernetes, that's the one being leveraged. I believe you're more looking for advanced monitoring, which is in the context of the models, etc. Right?
Yeah, and you know, the connection between these two. That's when it becomes interesting, because you need to know how the model behave, how is that related to the performance, and you know, how to wrap it all together without writing your own code, because everyone have nowadays, you know, you have Seldon or you have a KFlow or TensorFlow. It doesn't make any sense to use Flask or something like that. So I think combining all of this stuff together, that's a big challenge today.
Yeah, no, I hear you. And I mean, if you look at more advanced, depending on, if you're looking at models deployed in production and if you want to monitor them, right, it's Seldon, you mentioned, right, there's KfServing, which is, Kubeflow serving. Both of them are very, very active in that area, right? So, and it's a combination of then, the traditional infra level monitoring around, as I mentioned, the CPU, GPU request tracing, request response time, right? But then, moving to the next level of model monitoring, like monitoring it for drift, anomalies, adversarial detection, right? So it's a focus in those projects, right? But to your point, yes, there is a lot, which still needs to be done in general to bring this all together in a much more cohesive, seamless way. Yeah. Are you aware of KfServing?
I haven't tried it, but I try to learn, from reading. I think KfServing have a good approach to try supporting multiple models as a service that just serve them without coupling the model to the code. Makes sense, but I need to give it a try, to run it probably.
Yeah, I would say at this point, if you're looking at something which is, multiple companies contributing, I think Seldon is great. One of the disadvantages of Seldon is that it's mostly Seldon which is contributing, right? So if you're looking at a project on model serving on Kubernetes, right, where multiple people are coming together and collaborating and contributing, I would say KfServing is the right one to choose. Yeah.
Cool, thanks for the tip. It's really good tip.
Thanks. Is there anything, Terry, on your side in the agenda to bring up?
Yeah, so we're just coming to the end of the work on the technical requirements section of the document. So really last call for any contributions on the challenges table and technical requirements tables. In the next session, we expect to finalize those and then move on to just looking at the potential solutions table. So hopefully we're now relatively close to finalizing the first draft for this year's roadmap. But as I say, happy to accept any contributions over the next couple of weeks.
Okay. Okay. I mean, if that's something you want to provide, point Amog to as well, right, where it is, so that if he wants to go through it and take a look and see if he can contribute. Okay. Nathan, what's up at your end?
Yeah, this is my first meeting. I just joined the Slack and the working group.
Great. So what's the interest area? I mean, what's the interest from your side particularly?
Yeah, so I used to work as a data scientist, and I've been as a data engineer more for the past few years. I work at DocuSign, and we've just been working on building out the data lake infrastructure for the company. And getting past that, I want to get back into the ML space. And so we use a lot of managed services, at least when our team. So my interest is in, say, if you're using some sort of canned compute to serve a model, what is the ML specific monitoring, what does a dashboard look like to monitor the health of the model itself around that, and what are the best practices, and what is does that look like? So that's my interest, but I also happy to learn about just about anything in this space. I like it.
Yeah, so in general, so it looks like, aligned to what Amol was sort of asking as well, right? So,
Yeah.
I mean, data side, like when you say managed services, what did you end up choosing and using for as technologies on the data side?
We've been working with Spark for the most part, EMR Spark. I think depending on what the use case for ML, if it didn't have to be something really low latency, I would probably try to throw it into a Spark job like that. And then I'm curious, how would we build a system, and like what kind of regular checks would you have to run if you just get say you run predict and you get a column with all the predictions? Like, what do we have to do to check the health of that on a regular basis?
So yes, a Spark-based model for serving.
Yeah, it would probably be like Spark. Yeah, maybe a Java.
I don't know. If you want to contribute to Nathan, as I was mentioning, right? I mean, this project is probably, I mean, we don't support Spark-based models, right? There is a custom model support, which means, you can bring anything inside a custom container, but by out of the box, it's, TensorFlow, PyTorch, Scikit-learn, XGBoost, Onyx, and TensorRT. Right, which is supported, but I think it would be great to have someone. So far, we haven't heard much in terms of serving Spark ML based models, right? But if that's something which you would like to contribute, the core area is like in the sense that, skip this. There are multiple, as I mentioned, companies contributing here, right? So it's being driven by the requirements, right, which is being raised by the participating vendors. So far, Spark ML hasn't surfaced up to the top, right? So, but I would say things like CatBoost, right? CatBoost, for example, comes quite often, but not enough to cross that threshold where one of the companies which are participating or contributing, right, they have a strong driver to support that. So hence it sort of falls into that custom model scenario that, hey, if you have something which is not supported out of the box.
I think a lot of the Spark ML libs can save an ONNX file, maybe a PMML file. I'm not sure.
Yeah, and this is a pretty pluggable, right, in a sense that you can build your own. Like, for example, for TensorFlow, we use KfServing behind the scenes. NVIDIA's TensorRT server is used for PyTorch, XGBoost, and Scikit-learn. We use our own custom servers, right, which are Python-based servers plugged into KfServing, right? So I would say it's probably 2 to 3 weeks of effort to spawn a model serving backend for a particular kind of model, right? So if, as I mentioned, it's built in that way so that you can bring your own runtime. Or the other part is, if Spark ML has a production model serving runtime, right, and which can be plugged into that can be one angle as well. But I think the key advantages you start getting here is that, like there is this concept of transformer, right? So a lot of the pre-processing and post-processing code, which you bundle with your model together, and most of the models, right, in production, you're probably running on GPUs. You don't want the pre-processor and the post-processor to consume your GPU horsepower, right? So the transformer gives you a pluggable mechanism where your pre-processor, post-processor, they're all running on CPUs, but the main model predict code is on GPUs, right? So, and then there is, the standardization effort around the data plane protocol, right? So the goal is that, you are not going to change, or you should not be changing your model client code if you are moving from KfServing to Selden to TensorRT to TFServing, right? So we are standardizing around the data plane as well. So I mean, for someone in the Kubernetes world, it's pretty straightforward, right? I mean, it's define YAMLs, where your model is, what kind of model it is, and that's pretty much what you need to do, and very easy to define, default and canaries. If you're rolling out canary versions and you want to route a particular percentage of the traffic to your canary, that is supported, right? And then, behind the scenes, as I mentioned, pretty consistent, where you can use KfServing or you can use NVIDIA's Triton Inference Server, PyTorch, all with the same syntax and semantics, right? And you've seen a lot of these, right? There is the main predictor, which we are saying run on GPU, and then the transformer, which is, the pre and post processing. We are not saying, or we are not asking the MIS system to run it on GPUs, right? And then there is auto scaling built in. We leverage the Knative auto scaling, which is request based and queue based auto scaling, as opposed to a scaling based on the resource consumption, right? Because the scaling based on resource consumption of GPUs and CPUs in general is not going to be consistent. And this gives you a much better mechanism. And then, you get a very strong, solid mechanism to send traffic to both default and canary, split them according to the percentage you want, test it, and then you can use it. Yeah, so I think if there is an interest into this, right, and then there is a lot of the monitoring capabilities right now, to the point which was brought up, right, in a sense that, do we have a dashboard which brings everything together now? So there is not a single UI. We are working on a UI within IBM currently, which I do intend to open source at some point, right? But all of this is command line driven currently, right? But you can get more advanced capabilities around outlier detection, adversarial detection, concept drifts, all right. So we collect payload logs. And by virtue of, collecting these payload logs, we can enable your payload logs to go to your persistent backend, whether it's, Kafka or Knative broker or relational DB, and then run analysis on top of it, right, to provide these advanced monitoring characteristics, right? Additionally, you can get explanations, right? This is a project, for example, which IBM open source, now it's part of Linux Foundation AI, right? So that's also integrated in terms of getting explanations and things like outlier detection, adversarial detection, concept drift, right? They're integrated as well. So I would say this probably at this point is the most advanced one in the space, right? If you are looking at, production model serving and monitoring platform, right? In terms of the things like, we don't have a dashboard bringing everything together.
Yeah.
But yeah, so somewhere, it's also like, even if people are building dashboard, that's, probably the one thing they want to make money on. But I'm pretty sure, we'll get a dashboard in the community very soon. And even though, a basic one, and then, start evolving it towards a more mature one as we move forward.
Cool.
Thanks. Okay, anything else? We can give some time back. Yeah, and if you need to know more about KfServing, where to contribute, where the meetings happen, etc. I mean, just, ping me on the MLOps SIG channel, and then, I can redirect you to the right places.
Thanks.
Thanks. Terry, anything else do we need to bring up as we can call it?
Nothing from me, thanks.
Okay, thanks everyone, and talk to you next time.
Bye now.
Thank you.
Animesh,
Hey.
Animesh, how do I pronounce your name?
Animesh, ANIMASH.
Animesh, sorry. Can I invite you for a Zoom call with my partner and ask you some questions about your challenges in your organization and etc. It looks like you've met a lot of issues and you handle them in a specific way, and maybe you can help us find some things you think that we should solve.
Yeah, you're on the MLOps SIG channel, Amol.
Yeah, of course.
Let's use that maybe to find some time. Yeah.
Okay, thank you. So I'll PM you over there.
Okay. Thanks, man.
Thank you very much. I appreciate your time.
Thank you. Bye.
Bye bye.